not real. It's not real. I mean, honestly, any good person.
All right, take a look at Fred's here. Hey, be quiet. Too much talking here. Share.
Like I look at me, I look at the problem.
There's a lot of words there. I don't know that.
That's like I played reading today.
That's about it.
Yeah.
Oh, there it is. Now it pulls out. Yeah, I tested today.
Yeah, I had an issue. I fixed it. All right, so here's number one. Make sure you double check what you got. Negative 3x plus 38. Then turn around. 2 should be 25. 3 is negative 18. 4, all you do is put 20p. 5 should be 18, and 6 is 40 degrees. For that. Now, Jaylee said something about 6. What you want to do is take 5 minus negative 35. 5 minus negative 35. Okay, 7 through 10. So you should have 10. That's a negative 144 because the negative is not in parentheses. 9, that's 25 over 36. We did similar ones to those yesterday. 10, you are only looking at like terms. And it doesn't matter what order. So I got 15t to the third plus 7y plus t squared. And then, or you could switch the t squared to 7y. Some people did that. Brett?
What number is these ones?
No, because of the way it's written. Because here's the difference. When it is written like this, okay, that is where you do this. Oh, I'll wait till Mr. Slurs. Moved on. Okay, because you're squaring the 12, the negative's in front of it. If it was written in parentheses, that's when it's positive. Okay, so that's the difference between that one. You gotta be careful there. All right, 11 is quadrant 1. Okay, that's quadrant 1. Now 12, once we get to 12, we get to some of those equations. You should get x equals negative 4 for this one. 13, c equals 15, 55. 14's down here. 14, you should get x equals 5, but to answer that, you should end up with negative 4. 15 is z equals negative 14. 16 is negative 5. All right, 17, you got a lot going on there. I got x equals 5. How many people got that right? All right, good. 17. X equals 5.
Yeah,
All right.
oh, I know.
Like I said, this will be on Canvas so that you can scroll back through here and fix anything. And that's honestly, I tell you again, that's how you study. Just go back through any ones you missed, redo them. Redo it till you can get it correct without looking at the answer key. 18 should be y plus 5 divided by 3, or you could make that y over 3 plus 5/3. And some of you may have written, which is fine as well, 1/3 y plus 5/3.
Number 19 was the trouble.
Yeah, 19, some of you had questions on that one. And I think I didn't put nice numbers in here, so I think this is partially my fault. A video store charges a monthly membership fee of $4, but the charge to rent each video is only $1.25 per movie, so it's 4 plus 125 M. Another store has no membership fee, but it costs $2.50 to rent a movie. How many movies need to be rented each month for the total fees to be the same? Well, really, you just set those equal to each other. And, whoops, subtract $1.25 M. And then we get 4 equals 1.25 M. Well, you're gonna take 4 divided by 1.25, and I don't think we get a nice number. So you get 3.2. So that's kind of that probably threw y'all. So about 3 movies. So you can't get it to work out exactly right, but since that's my fault, I would definitely accept 3.2 as your answer. Okay, but that, I know it doesn't make sense because you can't rent 3.2. And who rents movies anymore? Sometimes you do. And what'd you get for 20, Preston?
Z equals 4 and 30 equals 5.
You got 16 for your final answer?
4Z.
Okay, 4Z equals 16. Well, that would be your final answer. So add 2. I get 6Z equals 24, divide by 6. Z equals 4, but it says find 4Z, which is 4 times 4, which is 16. So that final answer needs to be 16 for that. Okay. On there. All right, now, don't forget, I handed out that note card yesterday. Caitlin, we'll get you one here. You're allowed to use a note card on the exam, and you can put anything you want on that note card. I would actually have that out now. Yes.
You said if we visit with like ourselves around. No, I didn't. I'm thinking about it. Yeah, because like I could get one of those big ones.
It has to be 3 by 5. You cannot, you put it on a sheet of paper and say it's a note card.
Well, no, you see those like big note cards?
It doesn't count. It has to be that size, 3 by 5. Nice try.
If I add like 2 cents.
No. Okay. All right, let's go through here, these guided notes, so that you can get, some problems done. Yeah.
What's the number called when it says y equals mx plus b?
That is slippery stuff for me.
We have to use that.
That's not bad.
I'll tell you
So you have like.
that. Let's do that. Colin. All right, like I said, you guys need to be quiet here, a little hyper. I would have your note card out. You're allowed to put anything you want on there. By me, you can put problems on there, you can put the review problems on there, you can put problems. The practice exam, it doesn't matter, you can put formulas. Put down what you think you need, any little notes for that. Jalen?
Are you gonna take the note cards after the exam?
Yeah, after the exam, you will turn in your note card. Okay, you will turn in your note card, so you cannot pass it on to your friend in 6th period or anything like that, so you will turn that in.
What if I don't have a note card?
You don't have to have a note card. Did I not give you one? I mean, I don't know what your point of the question is.
you have one?
No, this is more.
So I gave you one yesterday, right?
Oh, okay, then now I have.
Okay. so
What?
you write-
This is
What?
Yeah.
I'm like, why is he so shaky?
Alright, for this first one here, n divided by -5 is 1. Our whole goal is to get n by itself, and then you got that graph there to the right. Okay, Christian?
Can I do it?
Yeah, what we do?
You start by labeling it, like labeling the graph.
Well, how do I solve that? And then I'll label it. I'll wait to label it until I know what the answer is.
You put a closed dot.
No, we gotta do this first. We gotta do that first.
Oh.
Colin, what do you think?
Multiply by -5 on both sides.
And then
Good. Multiply both sides by -5.
oh, shoot.
Because what that does is that cancels this -5 here, and it leaves you n. But now, what happens when you multiply both sides by a negative? The inequality sign flips. So that becomes greater than or equal to -5. Now, I'm just gonna start in the middle where -5 is and just make sure, I'm just gonna do a couple to the left and a couple to the right. You don't have to do a ton. And now since it's greater than or equal to, that's where you shade to the right. So you have a solid dot. This is like, if you forget when you use a solid dot, this is what you put on your note card. So like greater than or equal to, or less than or equal to the solid dot. Greater than or less than would be a hollow dot.
What is this called?
Inequalities. Okay. Now for B, 4a is greater than -24, divide by 4. Now, since you look at the number you divided by, that is not a negative. You do not flip the sign for that. So that just stays greater than, and -24 divided by 4 is -6. And so I got -6, -5, -4, -7, -8 there. Open dot. Shade to the right. Open dot, shade to the right because it's just greater than. All right, now C has a little bit more going on there. Distribute your -5.
Just go back up real fast, please. Okay.
Got it? Okay, all right, so for C, distribute that -5, and don't forget when you distribute, -5 times x, -5x, -5 times -3, plus 15. Okay, now once you get to that step, just take a look there for a second. And Caitlin, what do you think we can do here?
Add 6x to both sides.
Okay, I would add 6x to both sides. Adding or subtracting does not alter the sign, so don't worry about the inequality. So that just gives you x or 1x plus 15 is less than or equal to -3. And I would subtract 15. And I get x is less than or equal to -18. So I'm just gonna put -18 in the middle there. Don't forget when I'm going, that's gonna be -17 and just -19 there. Less than or equal to. Solid dot, okay, because of the equal to part. And then you're gonna shade, you only shade, once you have the x by itself, okay, that tells you the direction to shade. Okay, do not, if you end up with an answer like 6 is greater than x, make sure you flip that around and make it x is less than 6, okay? Don't want to leave a number in the front of an inequality, okay, ever for that. Yeah. This one only has an X on the one side. You never want to clear out a side. We don't want to subtract that 8X. Okay, Christian?
Oh, subtract 5x.
Okay, good. I would subtract the 5X. Like you said, 3X is less than 9.
Divided 2.
All right, end up with X is less than 3. All right, graph that.
I forget how to do this next one.
Colin?
I have a way to know which way the arrow goes.
Say that again.
I said I have a way to know which way the arrow goes.
How's that?
You look at which way the triangle is pointing, and the arrow goes that way.
I agree, as long as you put the X first. As long as the X is first. Because otherwise it'll,
Yeah, no, not for years. That's what we use in 6th
I mean, look
grade.
at everything that's on it. It always goes that way.
And I've been using that since 6th grade.
It's fine.
yeah.
What's the difference when you like, how do you realize you can do something?
So, Brett,
If you, like in the course of a problem, you multiply or divide by 2, you flip it, but if you end up with an answer like that, then you gotta rewrite it with the X first. Okay.
We only do it when it's,
The second set of problems here, these are the compound inequalities. All right, now some of you had some issues with these the first time. Kind of got two things going on. It says -1 is less than or equal to 2X plus 5, which is less than 11. When you have this situation, this is where you want to get the X in the middle by itself. Still kind of do what we normally do, add or subtract, like, so get rid of this 5. So you'll subtract 5 here, but you got to subtract it underneath the 11 and the -1. So get rid of the -5, but you got to move it to the right, and then you got to move it to the left as well. Well, that gives me -6 is less than or equal to 2X is less than 6. All right, now those numbers don't have to be the same, one positive, one negative. That could be a -6, and that could be a 10, or it could be a 15. It makes no difference. Okay, that's just a little bit of coincidence there. What do I need to do to get that 2X by itself? Okay, Joe?
Divide by 2 on both sides.
Yep, divide by 2 in the middle, and then on the right, and then on the left. That gives me -3 is less than or equal to X is less than 3. All right, now I got mine already labeled. Take a look at your graph, and now remember, what will that look like when we graph it? Okay, Grant, do you remember?
Don't they both go different directions?
Not on this one, because if you think about this, if you cover up this first part, basically it's saying -3 is smaller than X, or X is bigger than -3. So X is bigger than or equal to, so it's a solid dot, the -3, but it's also, how do you interpret that? That says it's also gonna be what?
X less than 3.
Less than 3, so it has to be less than 3 at the same time. So this is the case where it'll be trapped in between there. So if you plug in like 0, if I plug in 0, I get 5 in the middle. -1 is smaller than 5, and that's smaller than 11. So those are the only numbers that you'll plug in that'll make that middle value fall between -1 and 11. Okay, so this one's a little bit different. We call this a compound inequality. So it's got to handle, it's satisfy both of them. So you would shade in the middle there. Now this one's an OR problem, and it has two separate kind of inequalities. So we got to solve those separately and then graph. And so S plus 3 is less than 1. Subtract 3. I get S is less than -2. And now on the other one, you add 7. And I get S is greater than or equal to +3. Or, okay. So you want to kind of treat these as both, you need both answers. Well, what's S less than -2 look like? Okay, we've been graphing these, so it's going to be a open dot at where? -2 going which direction? To the left. Greater than or equal to 3 is a solid dot going to the right. But again, like on your note card, if you kind of forgot how when to do solid or hollow dots, you might want to put that down. You can put any of these problems down, but kind of pick and choose. You can't fit everything on there.
Super small.
You write super, hey, as much as you can get on there. Because honestly, this is a good way to review and write those things down on the note card. Okay. Joe, you good?
I didn't know.
Okay. Those graphs didn't come out very solid, very tough to see, but you can see up here a little bit better. Domain. Sam, do you remember if that's the X or Y value? The domain are all the it is all the X values. The range is all the Y values. So what are all the X values that curve hits? Okay. It doesn't hit everything because it doesn't go all the way over to -6 and doesn't go all the way over to 6. But where does it start at, Jordan?
What?
Were you going to tell me what to write?
No, I was gonna itch in my head.
Oh, go ahead and itch. Colin.
Starts at -5, 1 and goes to 5, 2.
Yeah, it goes to starts at -5. Now for the domain, I'm only concerned with the X's, and it hits everything in between there because that's a solid curve. So it goes from -5 to 5. Now remember, how do I write that domain? I'm just trying to think, do you remember? Okay, was that Josh? Is that you? It involves that, but you gotta put a little bit more in there. It's trapped between -5 and 5, so it's -5 is less than or equal to X is less than or equal to 5. See, that's how you have to write it when it's a continuous curve.
It looks a lot like the inequality that we had, what was it, on number 2A there. It looks a lot like that inequality when we write it. And even when we do that, makes that blue line across that x-axis. It looks an awful lot like that too. It's trapped in between those values.
So think about the Y values. What's the lowest Y value it hits? What's the highest Y value it hits? And it hits everything in between there. So Christian, how do you think we're gonna write that?
So wait, the which one's first? The lowest one?
The lowest one. Bless you.
1 is less than or equal to.
-1. Now for the range, put Y. Okay, instead of X, so switch that around. And then what else would I put from there, Christian?
Is less than or equal to 4.
Okay. -1 is less than or equal to Y is less than or equal to 4. So basically it hits every number, every Y value between -1 and 4, because that's the highest and that's the lowest. So X's are left to right, Y's are up and down. So you should be, all right, now is that a function? Now it's been a long time
Yes.
because it passes the what test?
Vertical line test.
Okay, that means each X has one Y value. So even though I know it doesn't say it on there, I'm gonna put down this as a function.
When you write those the domain and range there, you're always using less than or equal to on this type of problem.
And let's see here, this one. All right, so this circle, now it's not perfect. I couldn't get it perfect, so, but it goes from -4, say that hits all the way at 4, just for make life simple. No, actually, that's not -4, that's negative what? 3, and that is 4. That's -3, that is 4.
These are some of the trickier ones on the first part of this, the early part of this review. Like, those questions on when we tested, those were always not the highest scored problems, so. This might be some information that I would put on my card.
It's okay.
So now they're both pretty similar. -3 is less than or equal to x, is less than or equal to 4. That means it starts at -3 and it goes to 4, and the range does the same thing. The only thing is I'm gonna put a y in the middle. Is that a function?
No.
No, remember, if you have an x that goes to 2 y's, it is not a function. Or it fails the vertical line test.
And here, again, all we're looking at is how far left and how far right, how far down and how far up.
Are we on the back?
Just want to keep that right and small.
Josh?
I got a question.
Yeah.
I can have like.
On what?
So the leafy one, how do you know what sign? Is it always gonna be the underline?
Well, if it goes all the way to that point, okay, it wouldn't be if I would do this. And I said, all right, it gets to there, but it doesn't include that point, then that would just be less than. Okay, but since it does hit the 4, okay, and it starts there, you gotta put the equal to part. As long as it goes all the way up and hits it, you include it. Okay, so for 9 times out of 10, it's gonna include it.
Then it's left to right and then down to up.
Yep, smallest to biggest, smallest to biggest, left to right, down to up. Okay. Now, one thing here, it says write a function that describes, so what that means, instead of y, you need to use f of x. Okay, so that's gonna be important. Now, you might say, all right, a bowling alley charges $5 to use a lane and $2.50 per game. So you might say y equals 5 plus 250x, because it says x games, but now I can't count that because it says write a function. So instead of y, put in f of x. Now you can either flip it and put the 250x first, or you can put the 5, it doesn't matter. Or 5 plus 250x. Okay, either way, but you have to have that f of x. And if this is an x, that has to be an x. If they said to use g, you'd have to say f of g. Okay, that has to match up. All right, so that's what you're gonna have for the bowling alley one.
You only use the f of x.
When it says function. Yep, only when it says function. Okay. All right, for g of x equals 4 minus 2x squared, find g of x when x equals 2, and then when x equals -5. It's just telling you to plug those in. It's telling you to plug those in and see what you get. You're gonna get a number answer, like 10 or 15. So g of 2 is 4 equals 4 minus 2. Take the x out and square it. Whoops, hold on, I got something wrong there. Minus. All right, watch this right here. Some of you kind of get in a bad habit. You cannot multiply this 2 times this 2 before you square it. You gotta do exponents first, or PEMDAS rules. And so g of 2 equals 4 minus, all right, 2 squared is 4. 4 times 2 is 8. G of 2 equals -4. All right, you do the second one. Let's see how many people get that right. Plug in -5. You can use your calculator.
Please use your calculator.
That was a G -5.
Oh, dear.
All right, Evan, what'd you get?
I think it's right, but 2 and then parentheses -5 equals 54.
So you got, the final answer was 54? I don't think it's right either.
I use the calculator, so.
I got negative 46.
I got 64.
Alright, negative 46, okay? Alright, where's your calculator, Evan? Ah, yeah.
I just wanna see if I can do it.
Make sure, whoops, yeah, -5 squared, that's positive 25. And now, this becomes 2 times 25, which is 4 minus 50. So you should end up with negative 46. Okay, for that one. Negative 46.
You punch it in exactly how it looks, that have g of -5 equals 4 minus 2 times -5 squared. Punch that in exactly like that and you get it correct.
4 minus 2. I don't even need to hit times. I can just put a parentheses, -5 squared, negative 46. Okay, graph this function using a table of values. Now I'm going to give you the table, -2, -1, 0, 1, and 2. All right, again, this is this x squared. This is where things can get messed up if you're not careful. What does that graph have to look like?
It's just like, finger.
What does it have to look like?
A line?
It's not a line. It's a U.
Oh.
Because of the x squared. So when you're done, if it doesn't look like a U, you gotta look and see what you plugged in. All right, let's make sure this first one is right. Plug in -2. Let me know what you got. Okay, Zane?
You want me to tell you?
Yep.
Alright, I got -6, -3, -2, -1, and 2.
Okay, now you have done a great job of showing everybody how not to do it. Okay, because don't copy this down. You said you got -6, right? Then what?
-1 or -3,
And then what?
-2,
Okay? Then what?
-1,
And,
2.
okay, so if I graph that, -2, -6, -1, -3, 0, -2, 1, -1, and 2, 2. Is that a U?
Put in parentheses.
Okay, now, you gotta figure out what you did wrong. Here's what you did wrong. When you plug in -2 to the equation, you absolutely, because it says square that number, you absolutely have to put it in parentheses. And now, whoops. Now that should be a 2. So this is a double check. This is why we talked about, all right, what should that graph look like? If it looks like a snake, okay, and this is the most common mistake we see. If it looks like that, then right there, that's a huge flag. So, all right, I gotta go back. I probably didn't put parentheses around it. So this should be, what did we say, 2? And what do you get when you plug in -1? -1? So now, -1 is here. 0, -2, 2 is here. And you also have to connect these points because we picked numbers. So make sure it looks like a U. All right, it's better make the mistakes now than Thursday. So get them out of the way. Guarantee you, Zane, you won't make that mistake Thursday.
No way.
No way.
I know.
All right, Morgan, you caught up?
Yeah.
I said Wednesday, you said yeah. No, I didn't.
Give the domain and range of the relation.
No, I didn't.
Wait, can you go back real fast?
Yep.
I cannot see those.
Hey, take a look at that last one. If you've already done this one, like, we're heading there in a second.
Wait, why'd you scribble up? Oh, wait, no.
Because those were wrong. It should be a 2, it should be a -1, it should be a -2. It should be a 2. Okay. And then I know your graph is a little bit faded.
I don't have it research.
All right, domain and range of the relation. Domain again is all your X values. And this is gonna be different than,
I'm good.
it's gonna be different than this one here because it's not a continuous graph. They just list numbers. So we cannot assume it hits everything. It only hits the numbers they list. Couple key points. Put them in order from smallest to greatest and don't repeat values. So for your X values, that's just your domain. Smallest to biggest, so it'd be -5, -3, -2, and 6. -5, -3, -2, and 6. Range are just your Y numbers. Okay, you would not use the less than or equal to part because it doesn't hit everything. It just hits those 4 numbers. And so for the range, what's my smallest one? -2, 2, 3, 4. All right, smallest to biggest. Don't repeat numbers. Don't forget domain is X. Range is Y. Is this a function? Take a look at each X. -5 goes to 3. Does -5 go to anything else? No. Basically, you're looking, do the X's repeat? Is there a repeat in the X? No. Okay, so that is a function. Okay. Okay. 21 to 41.